Running thread can indeed be used with other types of fittings and locknuts. However, it's crucial to ensure compatibility between the components. Several factors come into play when determining if running thread is suitable for a particular application with other fittings. Firstly, thread size and pitch are paramount. The running thread must precisely match the thread size and pitch of the fitting or locknut. Common thread sizes include, for example, 1/4-20, 3/8-16, and 1/2-13. An incorrect match will prevent proper engagement and compromise the joint's integrity. Secondly, material compatibility is essential. The materials of the running thread, the fitting, and the locknut should be compatible to prevent corrosion or other material-related issues. Common materials encountered include steel, stainless steel, and brass. Dissimilar metals can lead to galvanic corrosion, weakening the connection over time. Thirdly, taper and seal are critical, especially for certain types of fittings. Some fittings, such as tapered pipe fittings, rely on a tapered running thread to create a tight, leak-proof seal. Ensure that the running thread and fitting are designed to work together correctly to achieve the desired sealing performance. Fourthly, locknut style influences the effectiveness of the connection. Running thread can be used with a variety of locknut styles, including hex locknuts, jam nuts, and flange nuts. The choice of locknut should provide adequate clamping force to prevent loosening, especially in applications subject to vibration or dynamic loads. Fifthly, a thread sealant can enhance sealing or prevent leaks in certain applications. If used, follow the manufacturer's instructions for proper application of the sealant. Over-application or incorrect sealant selection can actually hinder the connection's performance. Let's explore some specific examples where running thread is commonly used with other fittings. In pipe fittings, running thread is frequently employed with tapered pipe fittings such as elbows, tees, and couplings. The tapered thread design ensures a tight seal, making these connections suitable for fluid or gas conveyance. In compression fittings, running thread can be used with fittings that utilize a ferrule to create a seal. These fittings are often encountered in plumbing and refrigeration applications, providing a reliable and leak-resistant connection. In electrical fittings, running thread finds application in conduit connectors and boxes. It provides a secure connection and a grounding path essential for electrical safety and equipment functionality. In automotive applications, running thread is present in various fittings such as brake lines, fuel lines, and suspension components. These applications demand high reliability and resistance to vibration and environmental factors. Caution is advised. While running thread can be used with other fittings and locknuts, it is always essential to verify compatibility and adhere to the manufacturer's instructions to ensure a proper and safe connection. Incorrect installation or mismatched components can lead to joint failure, leaks, or other hazardous conditions. Always consult relevant standards and guidelines for specific applications. Remember to consider the application-specific requirements, including pressure, temperature, vibration, and environmental conditions when selecting and installing running thread in associated fittings. This comprehensive approach will help ensure a reliable and safe connection. For instance, in high-pressure systems, the thread engagement length and material strength are critical factors to consider. In corrosive environments, selecting corrosion-resistant materials like stainless steel is essential. When dealing with vibration, using locking mechanisms like lock washers or thread locking compounds can prevent loosening. Furthermore, it is important to ensure that the running thread is properly cleaned and free from any debris or contaminants before assembly. Foreign particles can interfere with the thread engagement and compromise the sealing performance. Proper torquing of the connection is also crucial. Over-torquing can damage the threads or the fitting, while under-torquing can lead to loosening and leaks. Use a calibrated torque wrench and follow the manufacturer's recommendations for torque values. Additionally, inspect the connection regularly for any signs of wear, corrosion, or leakage. Address any issues promptly to prevent further damage or failure. Keep in mind that different types of running threads exist, such as National Pipe Thread (NPT) and Unified National Fine (UNF). Each thread type has its own specific dimensions and characteristics, and it's essential to use the correct thread type for the application. Using an incompatible thread type can damage the threads and create a weak or leaking connection. When working with running thread and fittings, it's also important to use appropriate tools. For example, when tightening pipe fittings, use a pipe wrench that is properly sized for the fitting. Using the wrong size wrench can damage the fitting or make it difficult to achieve the proper torque. Furthermore, consider the use of thread sealants or lubricants to improve the sealing performance of the connection. Thread sealants can fill any gaps or imperfections in the threads, creating a tighter seal. Lubricants can reduce friction during tightening, making it easier to achieve the proper torque. However, it's important to select a thread sealant or lubricant that is compatible with the materials of the running thread and fitting. In some cases, it may be necessary to use a special thread sealant or lubricant designed for a specific application, such as high temperature or corrosive environments. When disassembling a connection that uses running thread, it's important to use the correct tools and techniques to avoid damaging the threads. Apply penetrating oil to the threads and allow it to soak for several minutes before attempting to loosen the connection. Use a wrench that is properly sized for the fitting and apply steady, even pressure. Avoid using excessive force, as this can damage the threads or the fitting. If the connection is particularly difficult to loosen, it may be necessary to heat the fitting with a torch. However, use caution when heating fittings, as excessive heat can damage the threads or the fitting. After disassembling a connection, inspect the threads for any signs of damage or wear. If the threads are damaged, it may be necessary to replace the running thread or fitting. Clean the threads thoroughly before reassembling the connection. By following these guidelines, you can ensure that running thread is used safely and effectively with other fittings and lock nuts. Remember to always prioritize safety and consult with a qualified professional if you have any questions or concerns. Consider the potential for vibration in the application. Vibration can cause connections to loosen over time. Use lock nuts or other locking mechanisms to prevent loosening in applications subject to vibration. Also, consider the potential for thermal expansion and contraction. Thermal expansion and contraction can cause connections to loosen or leak. Use expansion joints or other methods to accommodate thermal movement in applications subject to temperature changes. When selecting running thread and fittings, consider the pressure rating of the system. Ensure that the running thread and fittings are rated for the maximum pressure of the system. Do not exceed the pressure rating of the running thread or fittings. When installing running thread and fittings, use proper techniques to avoid damaging the threads. Avoid cross-threading or over-tightening the connections. Use a torque wrench to ensure that the connections are tightened to the proper torque. Inspect the connections regularly for leaks. If leaks are detected, tighten the connections or replace the running thread or fittings as needed. Keep accurate records of all running thread and fitting installations. These records can be used to track the performance of the connections and identify any potential problems. Consider the use of color-coded running thread and fittings to help identify different types of fluids or gases. This can help prevent accidental mixing of incompatible fluids or gases. When working with hazardous fluids or gases, use extreme caution. Follow all safety precautions and wear appropriate personal protective equipment. Consider the use of specialized running thread and fittings for specific applications such as cryogenic or high-temperature applications. These specialized running thread and fittings are designed to withstand extreme conditions. Regularly inspect and maintain running thread and fitting connections to ensure their continued safe and reliable operation. Replace any worn or damaged running thread and fittings promptly. By following these guidelines, you can ensure that running thread is used safely and effectively in a wide range of applications. Remember to always prioritize safety and consult with a qualified professional if you have any questions or concerns. When selecting running thread for electrical applications, ensure that it is properly grounded. Grounding helps to prevent electrical shock and ensures the safe operation of electrical equipment. Use appropriate grounding techniques and follow all applicable electrical codes. When selecting running thread for plumbing applications, ensure that it is compatible with the type of fluid being conveyed. Some fluids can corrode or degrade certain types of running thread. Use running thread that is specifically designed for the type of fluid being conveyed. When selecting running thread for automotive applications, ensure that it is rated for the operating temperatures and pressures of the engine. Automotive applications can subject running thread to extreme temperatures and pressures. Use running thread that is specifically designed for automotive applications. When selecting running thread for aerospace applications, ensure that it meets the stringent requirements of the aerospace industry. Aerospace applications require running thread that is extremely strong, reliable, and resistant to corrosion. Use running thread that is specifically designed for aerospace applications. When selecting running thread for medical applications, ensure that it is biocompatible and sterile. Medical applications require running thread that is safe for use in the human body. Use running thread that is specifically designed for medical applications. When selecting running thread for food processing applications, ensure that it is food grade and resistant to corrosion. Food processing applications require running thread that is safe for contact with food. Use running thread that is specifically designed for food processing applications. When selecting running thread for marine applications, ensure that it is resistant to corrosion from saltwater. Marine applications require running thread that is specifically designed for marine environment. Consider the use of coatings or platings to protect running thread from corrosion. Coatings and platings can extend the life of running thread and prevent failures. Use coatings and platings that are compatible with the materials of the running thread and the environment in which it will be used. When installing running thread, use appropriate lubricants to reduce friction and prevent galling. Galling can damage the threads and prevent the connection from being properly tightened. Use lubricants that are compatible with the materials of the running thread and the environment in which it will be used. When tightening running thread connections, use a torque wrench to ensure that the connections are properly tightened. Over-tightening can damage the threads and weaken the connection. Under-tightening can allow the connection to leak. Use a torque wrench that is properly calibrated and follow the manufacturer's recommendations for torque values. Inspect running thread connections regularly for signs of corrosion, damage, or leakage. Replace any damaged or worn running thread connections promptly to prevent failures. Keep a supply of spare running thread and fittings on hand to replace damaged or worn connections. This will help to minimize downtime and ensure that equipment can be quickly repaired. Train personnel on the proper selection, installation, and maintenance of running thread. Proper training can help to prevent failures and ensure the safe operation of equipment. Consult with a qualified engineer or technician if you have any questions or concerns about the selection, installation, or maintenance of running thread. A qualified engineer or technician can provide expert advice and guidance. By following these guidelines, you can ensure that running thread is used safely and effectively in a wide range of applications. Remember to always prioritize safety and consult with a qualified professional if you have any questions or concerns.